This is the first video on factoring by grouping. And factoring by grouping fits into the general procedure down here. That is, it's especially important for four-term polynomials. Here's the general idea. You know from our previous work that both these terms share a common factor of a, which can be factored out, leaving x plus 2 inside the parentheses. The first part of factoring by grouping relies on you being able to notice that this has exactly the same form. That is, the a has been replaced by the binomial x plus 5. In the same way that a could be factored out from the first two terms, x plus 5 can be factored out from these two terms. If x plus 5 is factored from the first term, we have a factor of x inside, just like we had a factor of x inside here. When x plus 5 is factored from the second term, we had a factor of 2 left inside the parentheses, just like we had a factor of 2 left here. It's really important that you work with this idea until you're comfortable with it, since factoring by grouping depends on realizing that this form and this form are exactly the same. Let me just mention one last point. Sometimes students will say, well, where'd the other x plus 5 go? It went the same place the other a went. That is, there's really two factors of a here, an a times an x and an a times a 2. And in the same way, there's two factors of x plus 5 here. That is, an x plus 5 times an x, that's this term, and an x plus 5 times a 2, and that's this term. See if you can factor this completely. In this case, our common factor is k minus 4, and once it's factored out, we're left with k minus 2. Here's another one. Our common factor is 2t minus 5, which we can factor out, leaving 2t minus 3 inside the parentheses. See if you can figure this one out. Our common factor is 3m minus 7, but what's going on with that second term? Well, there's a factor of 1 in front that we didn't see originally, and then after factoring out the 3m minus 7, we're left with m minus 1 inside the second set of parentheses. Now, factoring by grouping relies on the technique we just worked with, along with GCF. And in fact, you can think of factoring by grouping as GCF 3 times. So let me show you an example. The first step in factoring by grouping is to look at your first two terms and find the GCF. And in this case, that's x. So if I factor out the x, I'm left with x plus 1. Now we go to the second two terms, and again, look for the GCF, which in this case is 2. After factoring out the 2, I'm again left with x plus 1 inside the parentheses. Now I have a binomial that both of these terms share. They're separated by this addition here. And so I can factor out the x plus 1, leaving the x plus 2. As always, you should check to see that you get back your original polynomial by, in this case, foiling x squared plus 2x plus x plus 2. Now the order is a little different, but it's commutative, and so if the terms are in a different order, it's still the same sum. See if you can figure this one out. The first two terms have a common factor of 2p. The second two terms have a common factor of 3. And both terms now have a common factor of p minus 2. And I check my work. How about this one? The first two factors have a common factor of 3m. And the second two have a common factor of 7. I just keep this subtraction right there. And you should always check your work, especially with negative factors. For instance, I want to make sure this is a negative 28 up here and a plus 7 up here, and that helps convince me that I've probably done things right. And then I factor out the GCF of 4m minus 1. Try this one. In this case, our first two terms have a common factor of p squared. Our second two terms have a common factor of negative 25. I factor out the negative 25 and I'll be left with p plus 1, and as usual I'll check to make sure that if I distribute I'll get a negative 25p and a negative 25 just like I started with. Now both terms have a common factor of p plus 1, which I can factor out. You might have this the other way around, that is, you might have p plus 1 times p squared minus 25, but it's multiplication, which is commutative, so the order doesn't matter. Here's another. The first two share a common factor of 2a, and the second two a common factor of 3. And then I factor out the 3a minus 4. Try this one. The first two have a 2x squared as a common factor, and the second two have a 3 as a common factor. And then I factor out the 2x minus 3, leaving 2x squared plus 3 in parentheses. And here's one more. I factor out the common factor of y squared, and the common factor of 4, and finally the common factor of y squared minus 1. That concludes our introduction to factoring by grouping.